Good afternoon, everyone. Welcome to I Square Maths Academy, where numbers actually meet mastery. Today, we are going to be looking at implicit functions. Now, remember, in our last class, we actually covered explicit functions. Now, let's look at this. Now, if y is equal to x squared minus 4x plus 2, y is completely defined in terms of x, and y is called an explicit function of x. Now, the reason is because y is at the left hand side and x completely is at the right hand side. So when the relationship between x and y is more involved, it may not be possible or desirable to separate y completely on the left hand side. E.g., now let's figure this. Xy plus tan y is equal to 4xy squared. Now, in this case, the relationship between x and y is much more involved. Yes, because here we have xy, here we have tan y, and here we have 4xy squared. Unlike the first one here, where we have y at the left hand side and x at the right hand side. So in such a case as this, y is called an implicit function of x, because a relationship of the form y is equal to f of x is implied in the given equation. Now we are going to be looking at how to find the derivative of an implicit function. Now I want us to look at this. I want us to start with this as our example 1. Okay, now example 1. Given that xy plus tan y is equal to 4xy squared, find the y all over the x. Yes, now we are actually starting with this as our example 1. Now, in this case, when you look at xy, you will see that here, this is a product of two functions, x and y. Yes, and this is a trigonometric function of y, and here we also have x, y squared. That is 4xy squared. Now, for explicit, remember, we always start with the y all over the x, then you differentiate. Now, in this case, you can't start with the y all over the x. Why? Because the relationship between x and y is much more involved. So the first thing here is to tell them differentiating term by term. So here we are going to be differentiating term by term. Yes. Now let's bring the equation here. We have xy plus tan y is equal to 4xy squared. Now, looking at xy, this is the product of the two functions. So it means here we have to apply the product rule. Now, applying the product rule, you pick v, and our v here, uv, our v is y. So you pick y, you differentiate x. And remember, when you differentiate x, it gives 1. Then here we have plus. You pick x, which is u. You differentiate y. Now, because we are actually differentiating with respect to x, it therefore implies that anytime or each time you differentiate y, you follow it up with the y dx. So it means in this case, when you differentiate y, you have 1, then you follow it with the y all over the x. Yes, why? Because we are differentiating with respect to x. Then plus. Here we have tan y. Remember we said when you differentiate tan x, it gives sec square x. Now in this case, because we're dealing with y here, when you differentiate tan y, it gives sec square y, then you follow it with the y all over the x. Now this is equal to, this is the product of the two functions. So you pick your v, which is y squared. You differentiate 4x, here you have 4. Then you pick 4x, you differentiate y squared. That will give you 2y. Now let me bring it down. That will give you plus, we have 2y. You pick y squared, differentiate 4x 4. Then now you are picking 4x. So we have 4x. When you differentiate y squared, it gives 2y. And because we are differentiating with respect to x, you follow it with the y all over the x. Yes, the y all over the x. So it therefore means that y times 1 is y plus x times 1 the y all over the x. Now give us x, the y all over the x plus sec squared y, the y all over the x will be equal to y squared times 4 is 4y squared plus 4x times 2y. That will give us 8xy. Then we have the y all over the x. Okay, now I want us to collect like terms. I want us to collect all of the y all over the x. So in collecting the y dx, here we have x, the y all over the x, plus sec square y, the y all over the x. Now when you bring this plus 8xy the y dx inside, it becomes minus 8xy, the y all over the x. Now this will be equal to, there we have 4y squared, and now we are taking this y plus y outside to the other side. So we have minus y. Yes, minus y. So here we have x, the y dx, plus sec square y, the y dx. Now bringing this plus inside, we have minus 8xy, the y dx. Now is equal to, we have 4x squared there before. Now taking this plus y to the other side, it becomes minus y. So now the y dx is common to the left hand side, or in the left hand side. So here we have the y all over the x outside. We are factoring it outside. So here we have x plus sec squared y minus 8xy is equal to 4y squared minus 1. Minus y rather. So now, getting the value of the y dx. The y all over the x now will be equal to 4y squared minus y all over, here we have x plus sec squared y minus 8xy. Okay, so now this is the value of the y all over the x. Now let me take it again. Because the relationship between x and y is much involved in this equation, so and we are differentiating with respect to x, it means each time we differentiate y, we follow it up with the y all over the x. Now let's look at this, xy. Xy is the product of two functions. Then here we have tan y, then we have 4xy squared. Now because xy is a product of two functions, it means we have to use the product rule to differentiate it. Now in the product rule, we said if y is equal to uv, that the y all over the x is equal to v the u all over the x plus u the v the x. Now it means in this case we have our u and v. So you take the value of v, this is v, that's y. When you differentiate x, you have 1, plus you pick u, that's x. If you differentiate y, you have 1. And because we are differentiating with respect to x, it means you have to follow it with the y dx. Plus, now here this is tan y. When you differentiate tan x, it gives you sec square x. Now because this is y, when you differentiate tan y, it gives sec square y. Then because we are differentiating with respect to x, you follow it up with the y dx. Now this will be equal to, now this is another product of two functions. Yes. Now I'm using my u to represent 4x and v to represent y squared. So now picking v, here we have y squared. When you differentiate 4x, you have 4. Plus, you pick your u, 4x. When you differentiate y squared, it gives you 2y. Then because we are differentiating with respect to x, you follow it up with the y dx. Now in this case, here we have y times 1 is y, plus x times y the y dx is x the y dx, plus here we have sec square y the y all over the x. is equal to y squared times 4 is 4y squared plus 4x times 2y is 8 because 4 times 2 is 8. Here we have xy, that's x times y, xy, then the y all over the x. Now the next step is to collect like terms, to collect all the functions that actually have the y dx. Now we have x the y dx plus sec square y the y dx. Now if you bring this 8xy the y dx to the left hand side, it will change to minus because here what you have is plus. So crossing the equality sign, it changes to minus. Now it's equal to 4y squared was there before. Now plus y is going out to make 4y squared, so it becomes minus y. So it therefore means that because the y dx is common to the whole of this, we factor out the y dx. Now the y dx outside, here we'll be left with x plus sec square y minus 8xy is equal to 4y squared minus y. Now making the y dx the subject of this equation, it means the y all over dx will be equal to 4y squared minus y divided by x plus sec square y minus 8xy. Now if you look at the numerator, you will discover that y is common. So it means I can also express this as the y all over the x will be equal to y outside because y is common. So here we'll be left with 4y minus 1 all over x plus sec squared y minus 8xy. Now that is the value of the y all over the x. So we're going to watch out for more examples and also how to apply this to finding equations of tangents and normals to a curve. Thank you so much and God bless you.